All right, so this is an example of using the substitution method to solve a system of linear equations, Foundations of Math 10. And it may be possible for you to trial and error x and y values to find out what the answers are. This method will save you some time. It's a little bit tougher to guess which values these might be. You might be able to do it. But, of course, we need to learn some methods to do this. So we just went over some examples. I wrote down some steps earlier, so I'll get you to help me with the steps. Step 1 is what? Can someone read it out to me real quick? What is it in your notes there? Isolate one variable from one of the equations. So you get to choose. Now, in this case, there is not one variable that's almost already isolated. So it's going to take a little bit of doing. So it doesn't really matter which one we choose. I'm going to choose this x, I guess. Okay, so let's isolate this x. So over here, I'm going to move over here, and we're going to go 4x equals 18 plus 6y, because I want to get rid of this to the other side. Now I'm going to divide by 4 for every term, so I can get x by itself. Now, we're going to have some fractions here, aren't we? That's okay. It's best to work with fractions. If you want to work with decimals, that's okay. I'm going to do this work with fractions, because as you move into the pre-calculus, you're going to have to work more with fractions, so I'll demonstrate that. So 18 over 4, what does that reduce to? 9 over 2, simplified. 6y over 4, what's that going to be? 3 over 2y, okay? Sorry, that's plus. Okay, so this one we have some fractions, okay? No problem. It's going to be a little bit tougher. That's okay. Now, step 2, I believe, says we isolate or we plug in this expression. We substitute here. This is the substitution method. We substitute the expression for this variable into the other equation, right? And so this, I got it from this equation, so we're not going to put it back in there, but we're going to put it in the other one. So basically, we are merging the two equations together by substituting what one of the variables will equal. And so I'm substituting here, merging the equations, because we want one equation with one variable. That's what we want to work with. So 5 now is not 5x here, because we're going to substitute what x actually equals. This is going to be 5 times 9 over 2 plus 3 over 2y minus 3y equals 18. So I've just put that right here. Everyone see that? We good? Okay, what do I do next? Yeah, now I isolate for this variable here in this single equation that I have, I isolate. So I'm going to need to expand this out. I need to multiply the 5 into these brackets to get rid of the brackets. So let's do that. So 5 times 9 over 2, well, that's going to be what? 5 times 9? 45 over 2 plus 15 over 2y minus 3y equals 18. So now I'm going to gather like terms. And so I see that we have two y terms here. Because this is a fraction, I'm going to need to write this as a fraction with a common denominator. So 3 actually is the same as 6 over 2. Right? That's 3 over 1. I'm going to times 2 to get a 2 in the bottom, just like this fraction. And I'm going to multiply the top by a 2 as well. So I'm going to just substitute this 3 for a 6 over 2. And so I have 45 over 2. I have 15 minus 6. What's 15 minus 6? Plus 9 over 2y equals 18. Okay. So I need to continue now to solve for y all by itself. So I'm going to subtract 45 over 2. All right. And that gets rid of this over here. We've got 9 over 2y equals 18 minus 45 over 2. Well, 18 is actually 36 over 2, right? So 18 can be changed to 36 over 2. And 36 minus 45 is what? Negative 9. Negative 9 over 2. Okay? All right, so we're getting close. We're getting close. 9 over 2 and 9 over 2, really it's the same number here, so that's kind of handy. Really, if you divide by 9 over 2 now, which I wouldn't normally suggest dividing by fractions like this. Usually we're going to flip and multiply or something like that. But you can pretty easily see here that this is a negative number divided by the positive version of itself. So y is just negative 1. Okay. So there's a little bit of work with fractions there, and I know that's maybe not the most comfortable for you, but you may as well get kind of used to working with fractions here. Just remember, if you have to add or subtract, you have to have a common denominator, and then you just combine the top numbers, leave the denominator alone. Okay? All right, so y equals negative 1. Awesome. The next step is I take that value that I just substituted, because I've got half my answer now, and I just substitute that value into one of the original equations. It doesn't matter which equation you use at this point, doesn't matter at all. And so so negative 1. So I tell you what, let's plug negative 1 into this original equation here, number 1. So just save myself some time recopying here. So y is negative 1 now. So I'm going to take that y out, and I'm going to write this, negative 1. So 5x minus 3 times negative 1 equals 18. That's 5x plus 3 equals 18. 5x is going to equal 18 and then minus 3. And x is going to equal positive 3. That part was a little bit easier, wasn't it? So here we have our prospective solution, 3, negative 1. That's what I'm looking at, 3, negative 1 as an answer. The final step here is you should check, okay? You really ought to check to make sure that these values are indeed correct. And so if we're going to check, what we're going to do is we're going to substitute both values in and make sure that we have the equation is true. So this is a formal check. This is how you do a formal check. You would substitute the values of 3 in for x and negative 1 in for y and see if the equation is true. So I'll just do that real quick for you. 5 times 3 minus 3 times negative 1 equals 18. That's 15 plus 3 equals 18. That's enough for me to say that that works. 4 times 3 minus 6 times negative 1. That's 12 plus 6 equals 18. Absolutely. So the check has proved that this is the solution. And if we were to graph these two lines, we would see that they would intersect at the point 3, negative 1. So in order to check with our graphing calculator, what do we need to do in order to put these equations in to the calculator? Yes. Change the form to y equals mx plus b. That's right. Because that's what our calculator is going to understand. So if you look at the y equals, you see it's already y equals, and we have to find out, in this form, we have to plug it into the calculator in that form. So we've got negative 3y equals negative 5x plus 18. Y equals 5 over 3x, and then divided by 3. That's going to be negative. What's 18 divided by 3? Negative 6. Okay, so there's the 1. And the second one here then, divided by negative 6. We're going to have positive 4 over 6, or 2 over 3x. And this is going to be minus 3. Does that look right? I've done all my mental math correctly? Okay, well, we'll see. So let's plug the first one in. Again, when you're plugging these in, please use brackets for your fractions, okay, or your coefficients like that. So 5 divided by 3 bracket times x. You can just put the x there, you don't have to put times. Then minus 6. That's going to be the first one. Second one then is going to be bracket 2 divided by 3 x minus 3. And then what we'll do is we'll graph that. And it looks like my window is not a standard window, but we do see that they intersect. So let's go to zoom 6, because that's your standard window. And we should see that they intersect. Now, what was our solution here? We mathematically determined that the solution was 3, -1, right? Does it look like that's reasonable? 1, 2, 3. Oh, -1. It looks like it's reasonable. Let's go ahead and confirm. So second function trace gets to the calculate menu. That's second function trace. We'll hit number 5 for intersect. The calculator is going to ask me if that's the first curve, and it's going to show you the cursor blinking on one of the curves, and it's mentioned up here. You say yes. There's the other one. You say yes, and it says, do you want me to guess? Yes. And then the cursor should blink at the intersection point, and look at that. 3, -1. That's the answer that we got, 3, -1. So we've confirmed it as well by graphing. Okay? Any questions there? All right. So that's what you're going to need to know how to do for 7.4 is the substitution method. That's what's important. And 7.3 was using the graphing technology to determine the solution. So that's a little bit of lesson on review lesson on both.